Alright, good afternoon and Assalamualaikum. I hope all of you have taken your attendance. Okay, have scanned this QR code. Is it okay? No one have problem with the QR codes? Oh, so we should wait for Daniel, is it? Okay. Faster Daniel. Alright, I hope you already have done the practice, this practice that I have put inside the e-learning website. Yeah, wait. Mana ni? All of you have done your practice. Have problem with any of the questions? Okay, so today, for just who just entered the chat or the video call, if you want to use the QR code again, please let me know, okay? Then I will show you again this QR code. Oh, okay. Wait. I need to show you this again. Okay, faster. Take your attendance first. And then we'll proceed with the... Okay. So I hope all of you have done your QR code scan, yeah? So we proceed with the question number 1. For this, example 1. Okay. Okay. Draw the output voltage of each rectifier for the indicated input voltages as shown in figure. So this is the types. I don't like the sound, yeah? Alright, Daniel, welcome back. Okay, so the 1 and 4001 are specific rectifier diodes. So this is the types of the diodes, yeah, usually. This is the types of the diode. So the VD of this diode is 0.7 volts. So what the answer for the this question? Have you tried? Oh, someone just coming. Okay. So the solution, first of all, you need to find the peak output voltage. Again, I need to show this again. Okay, faster, 2 minutes of this for this one. Yeah. Okay, next. So the peak output voltage, first you have to find the peak output voltage for circuit. So you have to consider, you cannot neglect this the value of this diode for this diode drops. So you cannot neglect it. So you have to minus the P input, which is 5 volts. This is the input voltage of the circuit. Right. So the input voltage should minus with the diode drops, which is 0.7. So you will get 4.3 volts. So next, the question asks you to draw the output voltage of each rectifier, right? So you have to draw the waveform of the output voltage. So since this is the half wave rectifier, okay, this is the half wave rectifier. So at the positive circle, okay, positive circles, so the currents can flow, okay, so it will gives you 4.3 volts, the peak of the waveform, yeah, at positive volts. However, for negative volts, since at negative voltage, yeah, there's no currents will flow inside here because this is going to be a reverse bias drop, reverse bias diode, sorry. So there will be no current flow at all. So no currents, no voltage will be detected. So it will be 0 volts, yeah. And then when it goes to the positive cycle again, so it will back to the positive cycle again, like this, right? So this is half wave rectifier. Okay, and the waveform gonna look like this. I think this is a very straightforward questions, and it shouldn't be any problem with this, yeah. All right. Okay, move to the next questions. So the next questions, same with the previous one. Okay, draw the output voltage of each rectifier for the indicated input voltages as shown in figure, and the this is the types of the diode. Okay, so the diode drops value for this diode is 0.7 again. Yeah, it's given to you. So the output same as just now. Okay, so the input peak, yeah, peak input will minus with the 0.7 volts, yeah, because you cannot neglect the diode drops value voltage, yeah. So it's gonna give you 99.3 volts. So if you want to draw the waveform, gonna look like this. Okay, 99.3 volts. Okay, don't forget to write the value of the peak here too. Okay, so if you not write the value of the peak here, we don't know what's the value of this waveform, the peak of this waveform. So if you didn't write the value, it's gonna be wrong too lah. Even though the waveform is correct. Okay, so don't forget to measure this value too. Right? If not, you will not get full marks. Yeah. All right. So next, for example 2. For example 2, determine the peak value of the output voltage for following figure if the turns ratio is 0.5. If the turns ratio is 0.5. So what does that mean? It means that the ratio of this transformer is 2 to 1. Okay, 2 to 1. So first of all, if you want to solve this question, first you need to know the primary voltage first, the peak for the primary voltage. So this is the primary voltage located at here, right? So the V primary, peak for primary will be same as V peak input voltage here. So the value will be 170 volts, right? So the peak secondary voltage is, okay, the peak secondary voltage is VP secondary will be equals to N VP primary, where okay, where this N, yeah, where this N is actually N2 over N1. Okay, so N2 over N1, this is N1, this is N2, right? So N2 over N1 is 1 over 2. So here comes the value 0.5. So 0.5 times 170 volts. So you will get at this secondary peak value of voltage is 85 volts, right? So next, you have to consider the voltage, the diode voltage drop. Okay, so if you want to get the value of the V up at the output, okay, so V voltage, the diode voltage drop. Okay, so if you want to get the value of the V up at the output, okay, so V output will be V peak secondary value, which is here, yeah, 85 volts minus 0.7 volts, yeah, you will get 84.3 volts, yeah. So this will be the value at the output, right? Okay. Up until here, I think still will be no problem. If you have any problems, just let me know, okay? Just interrupt me, it's okay. Okay, next. Find the average value of the full wave rectified voltage in figure below. So you need to know what is the formula to find the average value. So the formula is, I have given to you the formula right before. AVG, average value is equals to 2 VP, which is a peak of the voltage, yeah, divided by pi. Okay, so peak of the voltage is 15 volts, yeah. So this 215 divided by 3.14, the value of pi, Okay, so it will give you 9.55 volts, right? I think this is also a straightforward equations. So the key, if you want to solve these questions, you have to know the formula of average value for full wave rectified voltage. Be careful because the formula is different between full wave and half wave, right? Okay, next. Example 4. Show the voltage waveform across each half of the secondary winding and across RL, resistance load, when a 100 volts peak sine wave is applied to the primary winding here, in the figure. Okay, and you have to calculate what is the PIV, the minimum PIV rating for the diodes. Yeah. So first of all, what operation is this? Center tap or bridge? Which one? Oh, for those who just joined us just now. Which operation is that? Center tap or center tap ke bridge? Oh, this is attendance for those who just joined us. Which operation? Center tap. Center tap, right? Is this is center tap, right? Kalau bridge, it will look like this, right? It will look like this. Okay. So this is center tap operation. So first of all, like just now, okay, this is N1, this is N2. The transformer ratio is 2:1. Okay. So first of all, you need to know, okay, what is the N value for the transformer ratio, which is N2 divided by N1. Okay, will give you 1/2 or half, 0.5. So the total peak secondary voltage will be, how did you get this formula? This is from V secondary, okay, V peak secondary, V peak primary equals to N2 over N1. So since that you want to find V secondary, so V peak primary we're going to be here. So this is also can be regarded as N. So N VP primary, you will get the value of V secondary, V peak for secondary. So the value of V secondary, the peak value for secondary here is 50. Okay, 50 volts. Okay, since that center tap, the voltage is divided into two. One will go up, one will go down. So each of the voltage will carry about 25 volts. Okay, 25 volts. 25 volts. So if you want to draw, the waveform, so it will look like this. This is the waveform at the V secondary here. Okay, at this part. Okay, at this part. V secondary divided by 2. Okay, here. So here will be 25 volts. Okay, at this part, the diode drops is not considered yet. Okay, but at this part, at V out, you have to consider the value of diode drops, which is 0.7. So 25 should minus with 0.7, then you will get 24.3. Okay, so that's why the value here is 24.3 because you are considering the diode drops of these diodes. Okay, next, what is the minimum PIV? Okay, so the formula of the PIV is 2 VP peak of the out voltage, right? Plus 0.7 volts. Okay, so you know just now peak for the output voltage is 24.3. So you take again the value 2 times 24.3 plus 0.7, then you will get the answer 49.3 volts. Okay. Okay. So I hope this also will not have any problems here for you. So first of all, if you want to solve this kind of questions, yeah, please identify first which type of operation of the circuit. Either it is center tap or it is bridge, because each of them have different formula, right? Okay, next, for next example, determine the peak output voltage for the bridge rectifier. So this is already mentioned to you. This is bridge rectifier in the following figure. Assuming the practical model. Okay, so this is not ideal model. So this is a practical model. So you have to consider the value of diodes drop which have been given to you, which is 0.7 volts. Yeah. So what are the PIV rating is required for the diodes, and the transformer is specified to have a 12 V RMS. Yeah, this is not the actual value. This is the RMS value. Yeah, secondary voltage for the second standard 120 volts across the primary. So for this question, okay, first of all, what you need to do is you need to know for you to measure the PIV. So what are the formula? PIV for bridge is VP. P is peak, yeah. V peak out plus 0.7, right? Okay, and then all right. So the peak output voltage, yeah, taking into account the two diode drops, yeah, two diodes drops. Okay, so the peak of the secondary voltage value is 1.414 is actually from the square root 2. Okay, square root 2 VRMS. Okay, so VRMS is given to you, right? VRMS for the secondary voltage from here is 12. So VRMS of the secondary voltage times with square root 2. So you will get the answer is actually around 16.9797 volts, right? So it is nearly to 70 volts. So you can put approximately 70 volts. But if you want to use this value, is also okay, no problems. Yeah. So with this value, if you want to measure, you want to know what is the value of the output voltage. Yeah. So V secondary, V peak for the secondary waveform. Okay. Minus 1.4 volts. Why 1.4? Because for bridge rectifier, there will be two diodes will be on forward bias, right? Will be operating, right? So it cannot be 0.7. It is 1.4 volts. Yeah. So 17 minus 1.4 volts. So you will get 15.6 volts. Yeah. So this is the value for the output voltage. Okay. Output voltage. So now, since that you already know the value of the output voltage, so now you can calculate the PIV. So the PIV rating for each diode will be 15.6 volts plus 0.7 volts. So it will give you 16.3 volts. Okay. Okay, so this is the final answer. Okay, this is the final answer. Up until now, is it okay? VP secondary equals to minus VD. Yes, minus VD. VD is a diode drop. Yeah? Value for the diode's voltage. Okay, until now it's okay. Yeah? Shall we go to the next questions? Okay, next question. Determine the ripple factor. Okay, the ripple factor, which is R equals to VR dP VDC. Okay. Determine the ripple factor for the filtered bridge rectifier with a load as indicated in the following figure. Okay, so PP primary. Okay, this is the value of the input source. Yeah, VP secondary, and then the output. So there is a capacitor here, and there is a resistor here. Okay, so this is the value of the diode's drops. So first of all, the transformer ratio is 10:1. So N1, N2. Okay, so what is the value of N? N2 divided by N1, so will give you 0.1, right? 0.1. So first of all, you need to calculate at the primary. Okay, the peak value at the primary part first, right? So since that it's given to you VRMS, it is not absolute voltage of input source, it is RMS, root mean square, right? So what you have to do is you have to times with root square 2. Okay, so you will get the value of the V primary, which is 170 volts. Yeah, 170 volts. So the peak secondary voltage is, so this is again, yeah, the formula N2, N1. So N2, N1 equals to V2, V1. Okay, so this is also N, V2 over V1. So then you will get the value of this is, you will get 17 volts, right? 17 volts here. Okay, so next, the unfiltered peak full wave rectified voltage is, okay, 15.6. Why? You have to consider two diodes that will be in a forward bias, right? So two diodes operates. So it is 0.7 plus 0.7, 1.4. So just now 17.0 minus 1.4 volts, you will get 15.6. Yeah, 15.6. So these are the value for the rectified voltage. Okay, rectified voltage, or at the secondary. Okay, rectified voltage at the secondary part. So now you need to know, you need to calculate the frequency of full wave rectified voltage. Sorry, it is given to you. Yeah, frequency of full wave rectified voltage is 120 hertz. Okay, 120 hertz. Mm-hmm. 120 hertz. So the approximate, okay, peak to peak ripple, okay, voltage at the output is, okay, okay, this is the formula that you have to memorize. Yeah? VR is equals to, okay, VR, this is VR. Yeah, VR is equals to 1 over frequency times resistance value times capacitance value and times with the P rectified, the value had P rectified, okay, the value that you just found just now. Okay, so 120 hertz times 220 ohm times 1000 microfarad, that will give times again with the 15.6, and you will get 0.591. So you already know this value. So you need to find another value, which is the DC voltage value. Okay, so to find the DC voltage value, the approximate DC value of the output voltage is determined as follows. Yeah, VDC is equals to, yeah, this is also, you have to memorize, this is the formula. Yeah, 1 minus 1 over 2 FRLC. Okay, F is the frequency, R is the resistance value, C is the capacitance value, times with the V that you found just now, okay, rectified value. So you will get the answer is 15.3. Okay, so 15.3. So you already know the VDC value. So you can just divide in 0.591 divided by 15.3 volts. So you will get the answer is 0.039 or 3.9%. Okay, given just 60. But then you have to make be careful, even though that it is given 60, but this is the this is the sine wave, right? So you have to take one full cycle, which is one full cycle will give you 120 hertz. Okay. Is that okay? For this question, the solution part, the calculation is quite long. So yeah, you have to be very careful for this one. Okay.
Doctor, we take 120 instead of 60 hertz, and then one full cycle, so it become 240 in the last column, in the last row.
In the last row, why it is 240? Oh, this one, because it is times 2.
Oh, so the original we take 120. Yeah.
The 120, yes. This is why it is 240, because it is times 2. The original is 120 for this one, okay? Okay. For VDC, memang it is the formula is 2 times 2. So that's why it becomes 240. Alright. The rectifier voltage is the same as output. Yes, the rectifier voltage is the same as output. Okay, the voltage that has been through the rectifier. So another word is rectified voltage, or the output voltage lah. Like here, okay, like here. Is that okay? More chats here. Okay. Because sometimes I didn't realize the chats here, so please interrupt me if I'm not responding to your questions here. Okay. So is that okay? So here, the value of the ripple factor for the questions. Okay. All right. Next, for this one, practice 2. Okay, have you tried these questions? Did you get the solution? How to solve it? Okay, first of all, yeah, looks here. Figure below shows a rectifier circuit with sinusoidal source, yeah, sinusoidal source, sign, yeah. Voltage which is V1 120, so VRMS, yeah. Be careful. So this is not the absolute value. So this is the RMS value, and RL is, which is resistance here. The value is 5 kilo ohm. Okay, 5 kilo ohm. So what is the transformer turns ratio? This value. What is the value of this N value? So that the the voltage here will be 6 volts amplitude at V2. Okay, N should be rounded to an integer. Okay, so how to solve this question first? First of all, yeah, N is equals to N2 divided by N1, right? I hope all of you have remembered this one, yeah? So N2 is given 1. N1 is not given, so you have to find this one, right? Which is N. It's given as N. So V2 over V1 is equals to N2 over N1, which is V2. It's already stated here. The value should be as close as possible to 6 volt amplitude. 6 volt amplitude means that the value here is 6 volt, right? So 6 over V1, the value is 120, but this is VRMS, right? So 6, 120 times with square root 2. Okay, square root 2. So you will get the answer 1 over N. So now here you can find the value of N, right? So N will be 120 times with square root 2 over 6. So you will get your answer N equals to 28.28, right? 28.28. So since that they stated here N should be an integer, so it should be 28 only. You have to neglect the decimals point here. All right. So the value of N is 28. All right. So this is the answer for number 1. Okay. For number 2. What will the actual peak, RMS and average voltages at the output? Okay, at the output. Let the diode has, so the V drop for the diode is VD. VD is 0.6 volts. 0.6 volts. Okay. So first of all, what you need to do is, again, you have to use this formula, right? So V2 equals to 120 times square root 2 over 28, right? Since that N2 value is 28, okay? So you will get the value of V2 is 6.06 volts. Next, you have to consider of VD, right? So 6.06 volts minus 0.6. Okay, so it will be 5.46 volts. Okay, 5.46 volts. Okay, so this is the value of the output. Okay, value of the output. Okay, value of the output. After you consider the voltage drop for the diodes, okay, 5.46 volts. So VRMS will be 5.46 divided by 2. So you will get the answer 2.73 volts. Okay, so this is the value for the VRMS. So average voltage be at the output, so VDC, yeah? VDC will be V peak, okay? V peak divided by pi. So V peak is this value, right? So if this value, they ask you to draw the waveform. So it will look like this, yeah? The waveform, the peak here, 5.46, right? So 5.46 divided by pi, 3.14, you will get 1.74 volts. Okay. All right. So up until here is clear, right? So let's move forward to the question number 3. Okay, I have to erase this part here.
Sensei.
Yes.
The VRMS is divide square root 2, is it?
VRMS
Sorry.
is
divide square root 2 or divide 2.
Divide square root 2. Oh yes. It's supposed to be divided by square root 2. Wait, yeah, I check first. Wait. Sekejap, It's supposed to be square root 2. Wait, yeah, di mana? Sekejap, I check my notes again. Scared I'm wrong. The handouts. The RMS for this is half wave rectifier. The average. Full wave rectifier. Half wave. What's half wave? Half wave rectifier. Okay. Half wave rectifier. VRMS. Oh, it's divided by 2. Sorry. It's divided by 2. It's correct. If you check my previous notes, I show to you my previous notes that I given to you in the previous class. Yeah. Okay, you can see here for half wave rectifier. Okay, half wave rectifier. VRMS is equals to V output, peak for the output, divided by 2. Okay. Alright. So it is divided by 2. It is not square root 2. Still okay? Alright. Okay. So let's proceed. Okay, I need to change it again. Proceed to the question number 3. This one. Okay, so let's proceed to the question number 3. Yeah, the peak current of the diode. So just now, wait. Okay. The peak current of the diode is here. Yeah. So you know just now that the voltage value here is 5.46. Yeah, 5.46. Okay, and the value of the resistor here 5 kilo ohm. Okay, so you are using the Ohm's law. Okay, Ohm's law. Okay, Ohm's law. So you will get the answer is 1.09 milliampere. 1.09 milliampere. Right? So yeah, this is very easy, I think. So you have to memorize the Ohm's law. Yeah, V equals to IR. This is very easy. Sorry, IR. Okay. So next, for question number 4, okay, for a 60 Hz input voltage V1 and a capacitor, okay, and a capacitor is added in parallel with RL to reduce the ripple. To reduce the ripple, in the voltage across the load resistance so that the drop is less than 0.25 volts. Yeah, calculate the minimum. So this is the value of the VRPP. Okay, this is the volt ripple ratio value. Yeah? VRPP, which is 0.25 volts. Calculate the minimum capacitance to achieve these conditions. Okay, so this one have forgot RF. Okay, so the minimum capacitance for this part. Okay, so this is the what we call this is the formula. Sorry, this is the formula. Okay, VP T T here. Oh, sorry. T here is 1 over F, right? Okay, T here is 1 over F. So frequency. So this frequency, why it is not 2? Because you have to careful with this rectifier. The voltage is only 1 times compared to just now. This one, the voltage. There are 2 diodes, right? 2 diodes forward becomes forward bias on the same time. So it means that the currents is flowing 2 times inside here. So that's why it is times 2. Okay, for bridge. But this is for half wave. So it means only one direction. Okay, to make sure that the diodes is operates. So the cycle will be only one. Yeah, so because okay, the cycle will be only one cycles. Yeah, so it is not 2 times. Yeah, so the frequency is 60, straightforward 60 as given. Okay, so T says that 1 over F, so 1 over F, so VP is 5.46, yeah, the value just now. Okay, the value at the output just now. So 5.46 divided by frequency 60, and then 5 kilo ohms, yeah, and then 0.25 is the VRPP just now. So you will get the capacitance value is 72.8 microfarad. Okay. Is that okay? Okay, Fahmi. So be careful, yeah, with the what kind of circuit and what kind of waveform that it will form. Okay, for bridge, the waveform that will come out here will be like this, right? Will be like this. So it means that once there are gonna be 2. The frequency will times 2. But for the half wave, okay, since that the output waveform kind of looks like this, yeah, that looks like this. So it will be 1 over only one cycle, 1 over 60 only, right? Okay, so these are the example that will come up during your test. Okay, during your quiz your quiz is going to be very easy, just around 15 minutes like that. But for your test, this will be come up during your test. For your test, I'll inform to you first. Yeah, for your test, the range. I give you the range of topics that will come up for your test. Yeah? So that you can focus on certain topics only, not all topics. The lecturer has discussed for your test the range. Oh, not here. Wait, yeah, I check my meeting notes first. Check try. Okay, here. Okay, so for your test, okay, only half wave will come out. Full wave will come out during your final exam. So for your test, yeah, half wave rectifier, and then Zener diode, yeah, ideal and practical. This one I will we will learn tomorrow, yeah. Zener diode, ideal and practical, and then the characteristics of Zener diode. Okay. Okay. Alright. So half wave, only half wave will come out during your test one. Yeah. Now full wave rectifier will come out during your final exam. Okay. And center tap will not come out. Okay, center tap will not come out. Bridge will come out during your final exam. Okay, so up until half wave rectifier and Zener diode, okay, will come out during your final exam. Sorry, during your test. Alright. Okay. So please study, okay, for your test. Okay, your test will be conducted on during week 6. Yeah, during week 6. Okay, so during week 6, study half wave rectifier and also Zener diode that we will learn tomorrow. Okay, so tomorrow we will learn about Zener diode. Okay, so the Zener diode also not all, only the ideal and the practical characteristics of Zener diode, and also the application voltage regulator, fixed V-in and fixed in voltage source and fixed resistance load. Okay. Okay, so tomorrow, yeah, we're going to look into detail about that. Okay, any more questions about this questions for your practice for today? I will, in case that you will not tak sempat nak salin, you will not have enough time to write just now the answer, I will give the answer to in your e-learning website, yeah, together with this recording session. Okay, any questions? Now we can end here and you can have your lunch. Alright. Okay. Yeah. Anyone doesn't have your attendance yet? Okay, attendance. Sorry. Forgot your attendance. For those yang tak sempat. Okay. So if you have any problem, yeah, please just let me know. Message me anytime, okay, or anywhere. Message WhatsApp also okay. E-learning website also okay. Emails okay. So see you tomorrow. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam. Thank you, Doctor.
Thank you, doctor.
Thank you so much.